Hi. This little video lecture here is for the timers we covered in class today. Really an extension of last week, so let's just go through it. So an ESP32 timer, documentation can be found here at this link. These slides are online. So a timer can be used to regularly call a task, initiate delay to call a task. Okay, commonly used to reduce the load on schedule by predetermining how often a function will execute. It's great. It doesn't have to go into a scheduler. It just gets called every so often, so many ticks, so many milliseconds. So just to look at how a timer works, so you create the timer, you get a timer handle. When you start the timer, it doesn't call the function at the time that you call the start timer. It calls it at the end of the time. So when you define the timer, you give it a delay time or a time variable. And what starting the X timer start does is it starts a timer, and at the end of the timer, once it's reached the allotted time, then it calls the function. So this is right out of the FreeRTOS documentation. Starting a timer ensures the timer is in the active state. The timer is not stopped, deleted, or reset. In the meantime, the callback function associated with the timer will get called in ticks after X timer start was called. And we convert ticks to milliseconds, right? So where N is the timer's defined period. So at the end of the period, the function gets called. So here's just how you create a timer. So timer handle T is returned, and you have to store that as a variable. X timer create is the call. It takes, look here, a const car name, period of the timer, right here, period of the timer, whether or not it's going to be auto reloaded, a timer ID if you want to change the default timer in ESP32, and the callback function that will be executed at the end of the timer. Okay, so the software timer is created using XTimer create, then the required memory is automatically and dynamically allocated inside the XTimer create function. If a software timer is created using XTimer create static, then the application writer must provide the memory that will be used by the software timer. That's a little subtlety we don't really have to dig too much into. And here is the actual ESP32 descriptions of PC timer name, so the text of the name, the period and ticks. The period ticks is right there. Auto reload true or false. If it's true, once the function is executed from the timer, it just resets itself. So if it's set to run every second, that function will run every second. And the timer ID right here is if you want to use one of the timers inside of ESP32, and then we have the bottom there, the callback function. All right, so timers are created in a dormant state, and then you call other functions to get them out of the dormant state. Here you have the X timer reset, start from ISR if you're inside an interrupt service routine. You can reset from ISR, you can change the period, and the timer change period from ISR. So there's some really powerful functions there, but we're going to really work on X timer start. Yeah, so X timer start, X timer ticks to wait. So the timer handle is the X timer, then the ticks to wait. X timer is a timer handle and returned by the X timer create function. And for ticks to wait, we can use 500 over this variable here, port tick period milliseconds, to have a function that gets called every half second or 500 milliseconds. And here's the basic process in a flowchart. So X timer create, so we get the timer handle. X timer start, take the timer handle, or you can do X timer reset. I'm missing an arrow here, but it goes, once it starts, it goes in timer waits, and then executes the function. And then once it's executed the function, it transitions back to the inactive state. Okay, you can then use the return timer handle variables to start, reset, start from ISR to move the timer into the active state. And so I posted 3 examples, but I want to go through really the last one here, timer 3. So what we're trying to do here is get 3 timers. Let me see if I can draw here. So we're going to have T1 is going to run its function, and then it's going to call inside the function T2, and then we're going to have another function. I should really say timers. So timer 1, it starts ticking away, get X timer start. After a certain amount of period, the period of the timer, it's going to call timer 2. And then when this one's done, it executes, it's going to call timer 3. And then when timer 3 is done, it's going to go back to timer 1. So we're into this loop of timers. So the 3 timers that call each other in succession, the timers will have auto relay turned off, and that's why we need to have them call each other. Okay, the main app function will start one timer. Each timer will call the next timer in an infinite loop. See if you can write this program on your own as an exercise. So you should go off and do that, hit pause. So we need 3 timers, right? If you think about it. So here in the app main, and I'm sorry it's missing, but these timer 1, 2, 3 have to be global variables. Yeah. So these two, timer handle, timer 1, timer 2, timer 3 has a global variable. If we zoom in down here, I can't zoom in. You can see timer, X timer create, my timer. It's going to delay for 1 second. Auto reload is false. This is if you want to specify timer. And then we're going to call timer task, timer 1 task, which timer 1 task. Now note, the timer 1 task has the handle timer handle underscore T, timer 1. And that's how this is linked to this. I know it's explicitly called, but this timer 1 ends up over here. Okay, and then if we look at the code, we're creating our 3 timer functions here, and this is our code down here. And if we go back, create a project called timer ex4, create 3 timers as shown here, and note the include statements. You should really use those include statements. And this creates the 3 timers in the dormant state. And then we need to create the function that start 1 timer. So really we start the 1 timer here, timer 1, okay? And then now we can add 3 functions the timers will run once. Note the timer 1 handle is the value returned by the xtask create function call on this line right here. Okay, so x timer start, timer 1, 0. 0 is a delay to starting the timer. So added here to start timer 1. Yeah, that's that right there. Okay. The code is shown here will only run once, right? Because we start timer 1 comes up and says, yep, I've executed, but doesn't call another timer. It could call itself, it could call another timer, many options, but really we're looking to create a succession of timers calling each other in a circle. Okay, and so here we have timer 1. So if you try to add x timer start to the function, either a timer handle T variable you're calling must be passed to the function or must be a global variable. And for this code, timer 1, timer 2, 3 become global variables. Yeah, there they are right there. And so timer 1 task receives timer 1, print timer 1 executed, and then you do x timer 2 start. So this starts the timer over here. So this executes after the 1 second delay, the 1 second duration of the timer. And then this one, because of this call here, starts. And then it prints timer 2 executed. And then it starts timer 3. And then timer 1 goes back and gets called. And so we get into this loop of activity of just regularly outputting stuff to the terminal. Now this is a very good thing to use if you want to have, say, an intersection. You can have one timer call the next timer, call the next timer, controlling the lights, okay? So when we do this, every second now, one of the timer functions will run in a perpetual loop. Timer 1, timer 2, timer 3, timer 1, timer 2, timer 3. You can extend this to a function and change the state of the digital output. You can do all kinds of things. You can change the DAC value, all kinds of things you can do. And that's the end of our the lesson here.